All right. I believe the test is Monday, Miss Olivia, unless if someone could corroborate that for me.
It is on Monday.
Thank you, Miss Madison. Yes, Monday. I mean, just be glad you're not in the other pre-calc class. Their test is today.
Are we gonna review tomorrow and Friday then?
Um, we'll review Friday. I mean, depends on how long it takes to go over today's lesson, but yeah.
Oh,
I mean,
okay.
and I'll be
I
available
thought there was
Monday.
only till there was only like till I thought there was only like till lesson 22. There's a 23.
There's a 23. I was corrected when I said 22. I forgot that there was one after that.
That sucks. Okay.
23 is easy in my opinion, so I mean, I don't think it's that bad. It's a pretty straightforward lesson.
Okay. And I was doing okay, so I was actually doing the homework. And I was doing 21 and I was wondering if you could stay after class and answer some questions.
I mean, I guess I could help, you know.
Okay, thanks.
You're welcome, Sweetie. All right, so section 23 is the binomial theorem. The first thing they introduce is part of the is a formula for what they call it's a combination formula. So it's NCR. You really just need to remember this. What this formula is a combinatorics thing. It's for you may have heard in the past. I doubt it, most likely. But you have combinations and you have permutations. There's two different ways of putting things together. We talk about combinations. Most people think of a combination lock. I'm assuming everybody knows what a combination lock is, yes? So I get one response. That's wonderful.
Yes.
Yes.
Thank you, people, for saying something. So, yes, a combination lock. Well, people lied to you your whole life. A combination lock is not a combination. That's actually what we call a permutation. Combinations are different. Combinations are things where order does not matter. Permutations are things where order does matter. Now, is that going to be any important to you in this point in your life? No. If you ever take a stats class, it will be extremely important to you, which most people will have to end up taking a stats class for a degree when you go to college. Um, so that's usually the pretty standard thing. They have everybody take a stats class. They kind of feel it's them getting a math credit and not having to do ridiculously hard math because stats is pretty easy in my opinion. Um, and in most other people's opinions too, it's easy math. So that's what they have you do. So you will have to at some point know that. Right now, not that important. With the binomial theorem, we only do combinations, so you don't have to know the difference between the two or anything. But I always like to tell people that because it's always funny. So our combination formula, like I said, it's the first thing in the book. You, I don't know if they'll actually make you do this by hand or not. I don't know. But just have the formula memorized. And I'll show you how to get to it in the calculator to check your answer as well, because you can put it in the calculator. So NCR is n factorial r factorial n minus r factorial. This is where we learned our factorials 2 or 3 lessons ago. This is where one of the places where we use them is in the combination formula. So what this is, for instance, if there are, let's see, how many people do we have in class? Okay, so from the 12 of us that are here, if I wanted to pick 5 people, how many groups could I make? That's a combination question. The reason it's a combination question, I'm just going to pick the first 5 people. Does it matter if I pick Abby, Britha, Dela, Harrison, or Madeline? If I pick those 5, does it matter what order I pick those 5 in? No, because it's the same group. So if I pick Brisa first versus Abby first, well, it's still the same group. It doesn't matter. That's a combination. When you start to get to permutations, if I was picking people for specific jobs, such as president, vice president, etc., well, I'd have to pick Mallory first because she's president, and then I'd pick so on and so forth. Then the order would matter. Does that make sense?
Yes.
Okay. Like I said, not super important for you guys here at this point in learning stuff, but it's always just nice to kind of have an idea of what this actually is, other than, oh, hey, this is just a formula. So that's what that is, honestly. You don't have to do much with it. You will use it, quote unquote. I don't know that I've ever actually had a student actually have to calculate these by hand, but you may want to have that formula written down and in your in your calculator. Sorry, I had something in my throat there. But that's up to you. Now to show you where it's at on the calculator real fast, because it's actually really easy. And I'll show you the different ways you might have to put in, because some of the calculators will be different. Okay, there we go. So you should use the calculator on the stream now, hopefully, yes. Yeah, it should be up. Okay. All right, so it's in your, you go to math, and we go over to probability on the fourth one over, and it's NCR is the one we're doing because we're doing combinations. Okay, you'll hit enter. Now you may have something on your screen that pops up like this right here. If you have the newer 84s, it definitely will, and you just put your numbers in. So like 10, choose 4. I don't know. And it'll give you answers. So if I have 10 people, I'm choosing groups of 4. There's 210 different possibilities there. If you don't have that, what you'll do is you'll hit 10, then go to math, and then go to NCR, and yours will say NCR, and then you'll hit 4 after it, and the 10 and 4 will be bigger numbers.
Okay.
And it'll be the same thing. You'll just have to hit your 10 first before going to NCR, or whatever number you're hitting.
And it's the answer is 210, right? Because that's what I got.
Yeah, 10 choose 4 is 210.
Okay, so NCR is the combination.
Yes. That's the only one you have to worry about. You don't have to worry about doing permutations in this class.
Okay, so if you didn't have a calculator, you would use the formula that you gave us, right?
Yep. And again,
Okay.
I don't know if I showed you this in the calculator. I think I did, but just to reiterate, click on the wrong thing. If you need to do the factorial, I think it's, yeah, same place. So the 4 down here, that is your exclamation point. That is a factorial button. You didn't miss much, Miss Livia. I'll go back over it real fast. So the factorial button, if you need to actually perform the factorials, you don't have to actually multiply it all out by hand. There is a factorial button. Okay, so on your calculator, Miss Olivia, since I know you have an older one, what you'll have to do is, let's say you're doing 10 choose 4, so the 10 and N and R is 4. You'll have to hit 10 first, so hit 10, then go to math, over to probability, and then we're doing NCR. Your calculator will say, oh, I hit the wrong, I wasn't paying attention. You'll hit, your calculator will actually say NCR, and then you'll hit 4, and then hit enter. Double check and try to make sure you do that and get 210. Just make sure you know how to put it in. So yours won't look like this one because you have the older calculator, but it still does the same thing. Your 10 and 4 will be next to NCR on the left and right hand side. That's all. That's the only difference you have. All right, sweet. They do some examples in the book. I'm not going to treat you like children. I'm sure you guys can plug numbers into a formula. Like I said, just make sure you either know how to do the factorial yourself by hand, or you do it in the calculator. And then always check it with the calculator. I don't think she's going to make you do a problem by hand necessarily, because we use that idea in the binomial theorem that we're getting ready to learn. But in case she makes you do it by hand, just make sure you have the formula ready to go. Okay. So the main use, and like I said, the reason we have that is we're going to use the NCR formula technically. The calculator does it for us, but we use the NCR formula in the binomial theorem. Okay. So binomial theorem. First of all, let's make sure we know. Can anybody refresh us on what a binomial is?
It's where you have two terms multiplied by each other.
It's unfortunately very close, but not correct. The two terms are added or subtracted by each other. And you forgot to say they are raised to a power. Well, binomial they are. So, in other words, you have something as a plus b, where we don't know what a and b are. They could be variables. As long as one of them is a variable, it's fine. How is this on the
Donald,
calculator?
have you turned off the calculator?
Yeah, I just saw what Abby said. Thank you for saying something as well, Harrison. I forget sometimes to turn off the calculator. There you go. It'll be up in a second.
Okay, what is this for again? Like the NCR?
It's a combination, which we're getting ready to use in our binomial theorem.
Okay, sorry.
You're fine. So a binomial is where you add or subtract two things together. With the binomial theorem, it's very important we make the note that we have to be adding. So we will have to do some algebraic manipulation sometimes. So a binomial, again, where you add two things, typically one of them has to be a variable. It's not going to be two numbers. That makes no sense. So one of them has to be a variable, and then we raise it to some power. So some of these are pretty easy. We've done squareds, and we even have a formula for cubes and things like that. However, what happens when I want to start doing something like, we'll just make it an easy one, x plus 1 to the 7th? Do you really want to take the time to start multiplying all that out? And I'm going to assume the answer is no, even though I'm getting silence. So that's great.
No.
Oh, look at that. I was right. But it becomes a giant pain in the butt if you want to multiply it out. The reason is because for every one you multiply, you go from a binomial to a trinomial, and you go from a trinomial to a quadnomial, et cetera, et cetera. So they keep getting bigger and bigger, much more calculations. Not very fun. So a couple different people have worked on it. One of the persons that is a pretty good idea, if you've ever heard of this, is Pascal. I'm assuming you've probably at some point done Pascal's triangle. Hopefully, if not, I'll show it to you today. But Pascal's triangle. You should have done that in middle school, but as I assumed, you have not. So, yeah, I'm learning lots of things that you guys don't learn anymore. We learned about different patterns and stuff. This is something a lot of people usually do in like geometry because it's like a pattern. So they do a lot of this cool stuff in geometry that I'm finding out they don't do anymore. So anyway, so the question is, how do we evaluate this in a much simpler term? Well, there's a lovely binomial theorem for us. So we don't have to do this out by hand. So instead, a plus b to the n, and choose 0, a to the n, b to 0, plus n choose 1, a to the n minus 1, b to the first. And choose n, a to the 0. We have a nice, lovely formula. Okay, now the thing you have not seen yet is that thing I have in front with the parentheses. The thing in the parentheses, the vertical looking set of ordered pairs or whatever you want to call it, that is your combination. That's how we know it's a combination. This is actually super easy once you figure out and see it. But the thing to point out, there are patterns to recognize. The first pattern is with your NCRs, your parentheses in the front. What do you notice about all of them? What do they all have in common?
An N.
They all have an N where?
Atop.
So the
On top of them.
N is on top, and where does N come from? So how do I know what N is, in other words?
Oh, N's gonna be the number that it's gonna be raised to, maybe, possibly, if I use the English right.
So not necessarily the number of terms. You got to be careful. That's a trick answer. It's close, but not quite correct, Miss Madeline.
The
Um,
exponent.
and yes, is what Miss Madison and now Brisa has noticed. It comes from the exponent of the original
English.
binomial. You're okay, sweetie. And yes, it is a 0. It's N on top, 0 on bottom. Okay, what else do we know about the parentheses out in front? So we know they all have an N on top. What else do we notice? There's something very easily.
A and B.
I said the parentheses.
Oh.
So Madeline picked up on it. It goes in order. The important part though is where does it start?
0.
Starts at 0 and counts up until I get to N. So 0, 1, 2, 3, 4. Okay. And then your A. What happens to your A each time?
It's being subtracted by 1.
Careful.
Or it's being subtracted by the previous term.
Careful.
You're
using the word it. What is it?
Oh, the N. Or the number.
What is
Or
the
the
N?
exponent.
There
The
you
exponent.
go. And Miss Madeline pointed out very well as well. Your exponent starts at N and goes down by 1 each time until I get to 0. Okay, well, what's happening to your B?
You're adding 1.
2,
Or not necessarily adding 1, but you're adding
2.
the exponent.
There you go. You've got to be explicit. The exponent is increasing by 1 each time. And where does it start?
0.
0. Okay, so now the question is, how many terms will be in there?
Isn't that going to depend on your exponent?
Well, yes, but we can say that it has, like, what is our exponent right now?
N.
So how many terms do you think that's going to have?
N.
Okay, so Miss Madison and Miss Madeline say N, and unfortunately, they're wrong.
Surprise.
Why does it not have N terms? What is this? What is this craziness? We talked about this. Where does it start?
0.
Where does it end?
N.
How many terms are there from 0 to N?
Depends.
No, does not depend.
There's N terms.
Miss Madeline figured it out. Remember, it's N plus 1. We did this with our summations. Remember where they were trying to trick you by starting the sum at 0 and,
Yeah.
and ending at like 7? From 0 to 7, there are actually 8 terms because you're forgetting when we count, we don't usually include 0. So you got to add that extra one in. So from 1 to 7, there are 7 terms. But from 0 to 7, there are 8 because you're including that 0 term. They are ends, it's a parentheses, it's a vertical set of parentheses that tells you what the two numbers are. So it's a numbered over another number, Miss Olivia. Okay, so we'll do a problem real quick. Let's see what's they got. X minus 3 to the 5th. Okay, so I'll leave this up here for our first one. Okay, so we got x minus 3 to the 5th. They gave you a not so nice one for the first part, but okay. So, what am I going to do first?
Plug it into the equation.
Well, it's not necessarily an equation, because that's a very long equation, but yes.
The theorem or whatever.
So, but what we went over a second ago or a minute ago, was showing you the pattern, so you don't have to memorize a theorem. It's a pattern. No, you really aren't, because that would be very long and very tedious, and you'll see why in a little bit. Okay, so at this point, you had to be careful, though. They're trying to trick you again. What did I tell you about the binomial theorem? It has to be what?
N plus 1.
Adding.
It has to be adding. This is not adding. So we need to rewrite this. This is x plus negative 3 to the fifth. And I put that in parentheses on purpose for a reason, and you'll see why in just a second. Now I can use the binomial theorem, and the binomial theorem becomes pretty easy. Okay, so when I do my first set of vertical parentheses, what's going to go on top?
Is it 5?
My
Or is it
exponents.
5? Or is it 6?
Oh, it's 5, because n is 5.
Okay.
And then 0 is going to go on bottom. Always starts with 0. What is my a term?
X.
It's x. I'm going to put it in parentheses, and you'll see why in a second. And then it's going to be to the n power, and then negative 3 to the 0 power. Plus, and then my parentheses, what happens in my second set of parentheses?
Negative 3.
No, I've already passed the negative 3 part. You might be behind on the video, I'm sorry. So what happens on the big set of parentheses on the second one?
Oh, 1 to 6. Is that what you're talking about?
Maybe wait till the video catches up for you. You should see a blank set of parentheses. The big one.
Yeah, it's 1/5.
No.
What? Okay.
5,
What
1.
number? There you go. 5/1.
Oh, that's what I meant.
So
Yeah,
you gotta be careful.
Sorry.
So 5/1. And then what happens to my x term? It goes to the what power?
4.
And then what happens to my negative 3?
It becomes negative 2.
No. Negative 3 never changes. Notice in the equation up here in the formula, whatever you want to call it, the b doesn't change. What changes?
The exponent.
The exponent. So what happens to the exponent on the negative 3?
It becomes 1.
It becomes 1, which I'm assuming either Miss Abby or Miss Olivia or somebody, Madeline possibly, typed in Discord. And then you just keep going. Hopefully you're recognizing the pattern at this point. I'm just going to start writing it out. Once you get this pattern down, this is honestly super quick. And all it is just time for writing it down. X squared negative 3 to the third. Because everything that changes is just a pattern. You're really like, I don't even pay attention to what I'm writing. I just know that my exponent goes down by 1, my number on the bottom goes up by 1, the other exponent goes up by 1, etc., etc. And I know I'm done when I have 5/5. When I have the same number on top and bottom, I know I'm done. Hopefully that makes sense to everybody before I go any further. All the exponents have to equal 10. I don't know what that means.
Okay, so like in the first one, it's 5/0, x to the fifth, and negative 3 to the 0. So 5 plus 5, the two things on top are 10.
Oh,
and
okay.
then
So
the next one is
hold on.
5, 4, 1, 5, 3, 2, 5, 2, 3.
So this 5 is irrelevant, so don't include that 5, the one in the parentheses. If you're talking about the exponents, you're talking about the 5 and the 0, the 4 and the 1. But then, yes, they do, and that's a very good thing to recognize. They do have a pattern, and they have to always add up to 5. Because that was our original exponent. So yes, that is a true statement. Just don't include the other 5.
But they have to add up to what n is?
They will always do that. It's just because n plus 0, n minus 1 plus 1, all the way to 0 plus n. They're always going to add up to that n value. And you're not really necessarily finding all the combinations. You're going in a specific order for a reason, and you'll see why in a future problem that we'll do. But yeah, Now, here's the part that can be very tedious, is calculating. Do you really want to do 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, etc., etc.? And that's probably going to be a fat no. So there is a quicker way in some cases of doing that. So before I finish the problem, we're going to learn that to use it. And that is where we get Pascal's triangle.
Wait, we don't get to use our calculator?
You can, and it's not a, like, I mean, it's just tedious to calculate 6 of them. So I don't like doing that if I don't have to. So sometimes it's easier not to. Sometimes it's easier to do it, and now we'll talk about, like I said, we'll see different examples where it's easier to use the calculator, where it's easier to use Pascal's triangle, etc., etc. So Pascal's triangle, in case you don't know, it's basically just a combination thing, very similar to when we looked at the, it's a recursive formula, like when we looked at Fibonacci sequence. So Pascal's triangle starts with a 1, and a 1. Marker not going right.
Wait, question. Okay, so
Wait,
that's
answer.
the answer, right?
Nope, we're not done. But we need Pascal's triangle to finish the answer quickly and easily. So we have the
What was
basis.
that for?
We need Pascal's triangle to finish the answer, sweetie.
Okay.
So Pascal's triangle starts out with a triangle made of 1s. Okay. We are then going to continue the triangle shape. In order to get the next number in Pascal's triangle, you add the 2 numbers directly diagonally above it. So in other words, my first row had 1. This one gets a 1, that one gets 1. So if I go out over here again, we get 1s on the end. 1s on the end will always happen very nicely for us. We're going to have 2 numbers on the first one, then I get 3 numbers, then 4 numbers, and then 5 numbers. So this number in the middle here will be made by the 2 numbers above it, and so on and so forth. Then this one goes here. And it's always the numbers that are diagonally above it. That one's kind of bad, but whatever. Just like the Fibonacci sequence where you added the 2 previous numbers, in this case you add the 2 numbers that are diagonally above it, left and right. So on the edges, there's only 1 number diagonally above it. There is nothing, so I can do that in black. There is nothing diagonally to the left of it because it's the start. So this just builds 1s, and same way this way. And I forget you guys can't see the different colors, so that was useless. So there is your beginning of your Pascal's triangle. We just need the inside. To get the numbers in the blanks, you just add. So to get the middle blank in the first place, what's 1 plus 1?
2.
So 2. Then to get the next blank over here, 1 plus 2 is 3, and 3, and then 4, and then 6, and then 4, and so on and so forth. What do we notice about the pattern? We should recognize something about each row.
It's the same number.
Each row.
Oh, not the same number. No, never mind. Your stream is late.
Oh, okay. I will go back over yes, Ms. Mal. So, but what do you notice about each row? There is something very important. I'm hoping that you guys know what that is. Well, yes, clearly 1s are at the end and the beginning of all of them. But there's something even bigger that I'm really, really hoping you guys are seeing. I don't think anybody's seeing it.
I'm definitely not seeing it.
Okay, starting at I'll start at the third row. 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Nobody knows what those are?
They're numbers, but that's about the best I got.
Oh man, this is terrible. What do they teach you guys? They're palindromes.
Absolutely. What the frick is that?
Mia actually talked for this.
What is a palindrome?
How are you guys in high school don't know what a palindrome is?
What is that?
I'm assuming everybody knows what the word race car is.
What?
The words race car.
I mean, I know what a race car is, and I just know anything else.
You don't know what the word race car is?
Oh yes, never mind. I got what you're saying. Okay. It loaded on the board, and now it makes sense.
I mean, I assume everybody would. What do they teach you people in public schools these days? Yes, Taco
Nothing.
Cat also works, Olivia. I might put a space
Nurse's
in between
Rhyme.
them. Okay, so word or number. Most of the time we talk about numbers. We don't usually use too many words. Um, but a palindrome is a number is read the same backwards as forwards. So if I know my numbers are palindromes, I only need to go halfway. Well, very fortunately for us, our connection is that these are our combinations. So this is 1, choose 1. Or sorry, 1, choose, actually, 0, my bad. And 1, choose 1 is the same thing. So we really don't ever look at that one. That's actually 0, choose 0, my bad. So this is 1, choose 0, 1, choose 1. And this is 2, choose 0, 2, choose 1, 2, choose 2. And this is 3, choose 0, 3, choose 1, 3, choose 2, and 3, choose 3, etc., etc. I'm not going to finish, that's a lot of writing. But those are our combinations, very fortunately for us. So the point that is trying to be made here with a couple of different things is, one, we can either use Pascal's triangles to know what those all are and be done, or we can at least use the fact that I only need to go halfway. Now sometimes
Well,
there's
I'm
an...
confused.
Let me finish and maybe you won't be. So if there's an even number, there is no halfway point in case you don't know. So you go to the where it's going to, before it starts repeating itself, which is you divide it by 2. So 4 divided by 2 is 2. 2 is not the halfway point because there is no true halfway point for 4 because it would be right here in the middle to cut that in half. So you would do these two and then those two are the same. For 5, the middle one would be 3. So 6 would be the middle, and then I only have to do the first 3 of them. The other 2 will then be repeated. So for this one, we have 1, 2, 3, 4, 5, 6. So if there are 6 of them, how many do I actually need to compute?
3.
3. And then what are the next 3?
The same thing.
They're going to be the same, but in the reverse order. So we can do that in one of 2 ways, like I said. Now to reiterate, because someone, I think Madeline's cut out, to get Pascal's triangle, you just add the 2 numbers that are directly vertically above it. So you have the first 2 lines are given 1, 1, and 1. The outsides will always, again, be 1s because there's only one number diagonally above it, which is the number either up to the left or up to the right. To get the middle numbers, you just add the 2 that are vertically above it. So there, and then there, and then there. So that's what the blue arrows are for. Now, if we want to use Pascal's triangle, we do need the next row for ours because we need the 5s. And in case you want to know, this is technically 0, choose 0, since I didn't put that one. So we would need our next row, so it's going to be, so the 5th row, because I don't have room to write it down there, is 1, 5, 10, 10, 5, 1. So if you don't believe me, you can calculate 5, choose 0. You're going to get 1. 5, choose 1 is 5. 5, choose 2 is 10. 5, choose 3 is 10. 5, choose 4 is 5. And 5, choose 5 is 1 again. So the numbers that are going to go in front of our variables for our combinations here are going to be 1, 5, 10, 10, 5, 1. That'll be what my vertical set of parentheses turns into. So here, for 5, choose 1, I'm going to turn that into a 1, because it's my first one. X to the 5th is just x to the 5th. What is negative 3 to the 0 power?
1.
1. So times 1, so I don't need to put anything there. So this whole first term right here, the 5, choose 0, x to the 5th, negative 3 to the 0, just turns into 1x to the 5th. Well, that's pretty nice.
Confused.
On what? I didn't do anything.
Okay, but like I'm just confused where you got. How did you get the 1x to the 5? Like that's where I got confused.
5, choose 0 comes from my Pascal's triangle. It's the first number, so it's the first one. So what's that number? 1. X to the 5th is just x to the 5th. And what is negative 3 to the 0?
Oh wait, okay. So how did you get the thing from Pascal's triangle?
Because I told you that Pascal's triangle is our combinations. So the first one is 5, choose 0, 5, choose 1, 5, choose 2, 5, choose 3,
gotcha.
5, choose 4, 5, choose 5. That's the nice thing about Pascal's triangle. That's why we needed it, to make this easier. In one of two ways. Either we directly use Pascal's triangle, which is a 1, 5, 5, or 1, 5, 10, 10, 5, 1, or we know we only have to calculate the first 3, and then the next 3 are the same thing but backwards. So either way, it saves us work, if we know that. Okay, so this again turns to 1, that's x to the 5th, and that's a 1. So multiply that all together, you get 1x to the 5th. What is 5, choose 1?
5.
Let me check Discover, make sure. No, it works for all numbers, Abby. Okay, so yes, 5. So this 5, choose 1 is going to turn into a 5. X to the 4th is just x to the 4th. Negative 3 to the 1st, I'm going to need to still multiply that by negative 3, because that's what that is. So we'll simplify that in a second. Moving on, what does 5, choose 2?
10.
We use Pascal's triangle. It's our third one. It's our third number. So 10. X to the 3rd is just x to the 3rd. What is negative 3 squared?
9.
9. So this is why I told you guys earlier to put it in parentheses, especially is because when you start using powers with this negative 3, you've got to be really careful. And then what is 5, choose 3? Or sorry, 5, choose 4, because we just did 3. Going crazy. What's 5, choose 4?
10.
Oh, wait, I'm off somewhere.
What?
No, we did 5, choose 2. I'm crazy. So 5, choose 3 is 10. Sorry, I was off a number. And then x squared times negative 3 to the 3rd, which is negative 27. And so on and so forth. I'm running out of room, so is everybody seeing where I'm getting all these numbers from now?
Kind of.
Okay. My suggestion to you, you have a copy of Pascal's triangle written down. So you don't have to write it every time. Just write it on a piece of paper. And this becomes really easy. Okay, Olivia is typing something. I'll wait for her to finish this.
We only have to go halfway, right?
Technically, yes. Some of them don't have a halfway, quote unquote, but yes.
Yeah, does this one have a halfway point?
Well, it's
Yes, it does.
6. Technically, no. 6 does not have a halfway point, really. It would be right in the middle of them. So it's weird when you say halfway point. Technically, even numbers don't have a halfway, but odd numbers do. Like when you talk about numbers of things, because you're talking about the middle term. We don't have a middle term for an even set. So it depends on how you define middle. Go ahead.
Question is what you just wrote the answer? Is that
No,
it? Or
I don't
do you
have
need
room
more?
to finish it. You got to finish all of them. I just don't
Oh
have
yeah,
room.
if after you finish it, is that the answer?
Yeah, you just need to simplify, like multiply the 5, like on the second term. If you look at that one, you had to multiply the 5 and the negative 3 to get you negative 15 x to the 4th.
All right.
That's the only other thing you have to do.
So just simplify and then it's
Yep.
done.
Yeah.
Cool.
So I can kind of do that for the ones I have, since I have a little bit of room. So this would be x to the 5th minus 15x to the 4th plus 90x cubed minus 270x squared plus da da da. And then finish off the rest of them. I just don't have room to finish it, really. I don't want to erase everything above it to write that answer. That looks to be correct. Yeah, you look good, Miss Madeline. That looks good. Okay.
Wait, where did you get x to the fifth? I thought it would be 5x.
Where? The very first one?
No, after 27. Negative 27, when you're going to the next term. 5 to the fourth. Wouldn't it be 5? Because you just did 10, you have to do 5.
You would. I didn't do any more terms. I stopped at that one because I don't have room to really finish
Oh,
everything.
you simplified.
Yeah, I simplified everything
Okay.
to show you what the final answer would look like. And if you want the full answer, Miss Madeline did type it in Discord very nicely for us.
Do we have to do the other 3 terms?
Yes, you would. I just don't have room to do it right now. Okay. Any other questions?
No.
Okay. We only have one other small thing to do on this tomorrow, and then we'll answer questions. My hint and suggestion to you guys, because nothing ever changes about these problems. Notice, if I sneeze, maybe, somewhat. I guess not. Okay, notice how every time I did these with the powers, I put them in parentheses. If you're not doing that, you will make a mistake on other problems. Especially with this being like a -3. That's a place where you'll make a lot of problems. This may not always be an x. For instance, you may end up doing problems that are like 2x plus 3y to the 8th. When you do that, make sure your 2x is in parentheses, so like 2x to the 8th, and your 3y is in parentheses. Stuff like that. Make sure you're doing that. If you're not following that little bit of advice, you will make mistakes with your exponents. Guaranteed, hands down, no questions asked. So that's my advice to you. Any other questions on anything we did? So we should have like one, actually I guess 2 super small things to go over tomorrow. Okay, then that will be class for today. Make sure you're doing some of the homework so you can ask questions tomorrow, please. And Bruce had questions but has already left. Okay. You guys have a good rest of your day.